Hi guys, and welcome back to another episode where we will be solving the Physics IGCSE 0625 poorly answered questions for you. So today we're still continuing with the May-June 2018 question paper 2-2 series. So let's have a read through the question as always. The graph shows how the count rate registered by a counter near to a sample of radioactive isotope changes over a period of few days. The background count rate is 5 counts per minute. What is the half-life of the isotope? Now this is very important because they gave you the background count rate over here. So if you kind of look at the graph, initially it kind of just becomes horizontal at 5. That means that the existing radiation, anything after it's crossed this point, is just going to be due to background radiation, not due to your sample itself. So if you look at it, initially your graph, I'm going to put this in purple, was at 45. So you need to take the background radiation into account. So that means where 45 was initially on the graph, which is 0, that's where 40 is now going to be on the graph. So you've taken away the background radiation rate. Where 40 was on the graph, right, that's where 35 is now going to be. Where 35 was on the graph, that's where 30 is now going to be. Where 30 was on the graph, that's where 25 is going to be. And where 25 was on the graph, that's where 20 is going to be. And where 20 was on the graph, that's where 15 was going to be, and so on and so forth. So as you can see, I've plotted the points. 40 becomes the new 0. Then 35 is, as you can see, over here, okay, and then 30 becomes here, okay. So you can see that we've got this new graph as we keep reducing it, and basically the initial count rate was now 40. So to find the half-life, we have to divide the initial count rate by 2 and we get it as 20. So then we go on to our new graph and we look at where is the half-life on the new graph at 20 counts per minute. So we find that it is at 2 days. Okay, so the answer is 2 days. You kind of have to plot a new graph and observe where the new times are going to be as per taking the background radiation away from your answers. So just to recap, when you take 5 away from 45, 40 is the new 0. Okay, if we look at 35, 35 was initially over here, okay, on the graph. Now this is where 30 is going to be. Okay, look at where 30 was on the graph. 30 was over here on the graph, and now that's where 25 is going to be. Look at where 25 was on the graph. 25 was over here. That's where 20 is going to be. Look at where 20 was on the graph. Now this is where 15 is going to be. Okay. Look at where 15 was on the graph. Now that's where 10 is going to be. So that's how we get the actual graph for only the sample, excluding the background radiation rate. Okay. So I hope that answers your question. Have a nice day. We will see you again tomorrow. Bye bye.